The virtual memory support can even disclose more mystery in a computer. Okay? The first big mystery is this big mystery triangle. This triangle, what is this? You have the CPU, you have the RAM, you have your memory allocation, which is supposed to be living in a yellow area, which is the user space area, is all the things. And people telling you that, hey, this bunch of things should be living here, right? Seems to be directly a bypassing kernel, right? Directly go to the hardware level, okay? And your code, okay, I got the wrong pointer here, okay? So point to the code. That guy read the code and also read from the memory to execute your code. And the last thing is maybe this CPU finished some results, putting it onto your variable again. As long as there's all hardware here, they use their box here to do the communication. And I say that this triangle is not very straightforward. Okay, from perspective of a system programmer, okay, these two guys are not talking very effectively. They have some communication problem. Okay, and if your hardware guys, you understand some part of the communication problem. Okay, they have different bus speed, they have different frequency. Okay, I'm not talking about this. Okay, although it's always false. Okay, I don't talk about the bus speed, the asynchronous problem. Okay, the dual channel problem. These two guys. Even more balls, okay? These two guys, the CPU try to get your memory, you write it there, but actually where it is, I show you the program. I show you the program first. Later on, I'll come back to this figure. This program, very interesting. I run it. Okay, so let me close this guy. I don't want this. I don't want this. Okay, so let's go to part 2. Same address.c. Okay, so this program we'll call fork, right? And before the fork, I create a variable called PID. Actually, no one asks these questions. I remember a few of you here asked the questions in this room. I discussed it in this board. Okay, basically the question is the PID. That copy of PID is in the parent product, right? And you call fork. I know fork doing a duplication of everything. So from the PID source, okay, you will duplicate the memory, also called PID, supposed to be different. So they should have different addresses. Okay? And I will run this program. All right. Same address. Go. What can you say about this? I have a conclusion. The conclusion is you're using the same program, running on 2 different processes, accessing the same variable, but the variable carrying 2 different addresses with 2 different values. What can you say about this? Strange. It can be, right? 2 different variables supposed to be different, right? Because you go from system called give you 2 pieces of memory, and I keep on reminding you that yeah, you believe in this, and you start to believe in it, starting from maybe first week or second week. Then now we go to the second last week. You tell me something so interesting. They are the same. They are the same. Same address. Now what can you say about this? Can you say same address means same variable? With this program, no. Okay, what is the address?
Different memory space.
Yes. No, something different, not about memory space. Okay? It seems that we are living in a dream world, huh? Really dream world. You dream of an address means a variable. I would say no. Address doesn't mean a variable. Address is an address, that's all. Okay? Yeah. Can you accept that? Someone tell you since the year one study all the way down, maybe now you're in the final year, is something tell you, oh, no? Okay? Yes. Yes, in the sense that this is an address, but we have a name for this address. This address, we call it virtual address. Virtual, false address. Okay? Just like what? Just like you want to apply something, okay? You want to buy something from Amazon. And Amazon want you to be a US citizen, and you give him a false address. Yeah. Some people buy something from Amazon in US, then you understand what I mean. Yeah, give him false address, yeah, mail it to the US, and then eventually you give the goods for me, okay? Using other means, right? You give someone a false address, and believe in that false address will deliver the items to you, but actually it's not that direct. This is that false address. Okay? You think that you go through that false address, it will eventually deliver the memory to the system physical memory, which is false. This is not the address in the system memory. The system memory, we call that a physical address. This is virtual address. And that means what? That means, first of all, who don't know what this diagram is talking about? Yeah, I first talk about the story. The story is we have 1, 2, 3 step. Some very old professor love to call it the fetch-decode-execute. I follow it. Okay. Yeah, he found it. I think that you were being taught by that guy. Okay. Yeah. The old story is you have an instruction or you have a piece of memory. Let's say this is a piece of memory. This is an instruction, and the instruction may be of this assembly code. You first ask the CPU to fetch it based on its instruction address. Fetch it, put it on the CPU knows that, oh, you want to add and move some address 1, 2, 3, 4, 5, 6, 7, 8 to this register on EAX. Okay, I do it for you. I go to the memory bus, go to this integer, which is also this address, 1, 2, 3, 4, 5, 6, 7, 8, copy it back to CPU. This is the old story. How many of you don't not heard of it? Yeah, it should be a no. Is it the nowadays ENGG 2020 talk about this? No. Then how about others? Why only 4? Then if that's the case, it will remain it, right? Is it you heard from other courses? You heard from other courses? No? You also don't know about this. I remember this ENGG 2020 has talked about it. In my time, okay? In my time. Okay. Okay. What is this course? It's not operating system course anymore. Okay? We have to teach this side. Okay, so if you have heard of it, forget about this. This is the wrong figure. This figure is totally wrong. What is the sense of this figure? The sense of the figure only comes with this address of really talking about physical address. And the truth is, inside CPU, there is a special unit called MMU, Memory Management Unit. A small hardware, just like table lookup hardware, inside the CPU. You cannot detach it, okay? It's already inside CPU, okay? And this little guy will stand before the CPU to communicate with the memory bus to the CPU, and this MMU, what is served for, is served to map virtual address to physical address. Why we need this matching? Take a look at the previous program code. The program code here, now I directly print the address from the program. That means inside all the memory for that process, they only know about its own world. Understand what I mean? They know there is an address of this number inside me, and then he is in another process. He also knows that, okay, I have this address, but we are different organisms, right? We're different. How come I have the same address, he has the same address? It's because the MMU is doing the tricks. Okay? Oh, sorry, wrong. The MMU, what the MMU is doing is very easy. It's a table lookup engine. an engine for table lookup. And let's say you are asking for PC, program counter. The program counter pointing to the instruction, and instruction address within the user space memory. The user space memory, there is a process. The process knows that, okay, my instruction address is this guy. But actually, inside the machine don't think in this way. The machine is first ask the CPU, hey, what this guy is talking about? I don't know this address. Please translate this address to the physical address, the physical world. Okay? Then after the translation, MMU is very fast, okay? Or we will have a big problem. Okay, we translate into this new address, and using this new address to access the physical world. And what is even more interesting is the data that's saved inside the physical world is not hosting. Okay, here is the host, right? The host instruction. It's not hosting physical address. It still hosts virtual address. So that when we ship this instruction, we'll ship the instruction now, ship it to here. Okay? Next, when we try to execute this statement, he will know, oh, 1, 2, 3, 4, 5, 6, 7, 8 is in a virtual world. So I need to do one more translation because I want to execute now. Ask MMU, hey, translate it for me. And eventually, oh, this translation give me a new address. Is I don't know, 1357980. Okay. Then go to there and look up this here. So what can you say about this? You can say about this in this way. The animation can show you this. Actually, we have a set of virtual address, which is only known to the process X. Process X has a set of physical address. And whenever you try to execute a program, you need to supply address and process address within your memory. Your memory needs to tell MMU, hey, I want such a physical address now. Please translate it for me. Although in the previous demonstration I used FOB, they become two separate address. So this process why maybe they have a relationship, what is parent and child is done through using a FOB, okay? So they carry some set of identical values because of the FOB. No, the value is the same, but you are two different processes. The MMU is a powerful tool. The MMU know who you are. The MMU know whether you're process X or process Y. I know you are process Y, so I give you an order mapping. Maybe sometimes I will map to the same address. This map to the same address. Sometimes I map to a different address. This is the basics of MMU. And what is the source? The source is we have multiple processes running at the same time. We cannot let multiple processes to access the same previously allocated memory from process X to process Y. We cannot share them. You cannot let one memory to store two different values. So we go through this translation. And this translation, the magic of it is this translation look table. How we construct it. Okay, we need to construct it so that he knows what is the process you are. You are process X. Okay, I give a new mapping A. You are process Y. I give you another mapping B. How they do it? How they can switch? Okay, or how to construct the content inside it. Next lecture I will talk about it. Okay, next lecture is about MMU implementation, how to implement MMU, as well as a new vocabulary called paging. Okay? So this is the start of something really, really hardware, not hardcore, okay? Related to hardware. Okay? So I will stop here now.